Welcome, Super Smarties. Let the learning begin. All right, so we're going to change up our calendar just a little bit again. Yesterday was not Tuesday. Yesterday was Wednesday. So we're going to move the Wednesday up. Here's my face space. Lace the face space. Yesterday was capital W, E, D, N, E, S, D, A, Y. And we're going to end it with a what? A period, because it's just a telling sentence. Remember, I want you to put this into your composition book or on a piece of paper or into a notebook. You can do it on a whiteboard or a white mat. Either of those are fine. Any of those are fine. So we're going to erase Wednesday, and now we're going to move Thursday up to today. Yesterday was Wednesday. Today is Thursday. Up lace, capital T, H, U, R, S, D, A, Y. And we'll erase Thursday. And let's go over here and check our smart chart. Sunday, Monday, Tuesday, Wednesday, Thursday, bing, 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 Friday. And this is a special day. It will be a special holiday. It's called Good Friday. It's Good Friday. So we wouldn't have been in school anyhow. So starting tomorrow and all next week, my Smarties wouldn't have been in school. That's good. All right, tomorrow will be, I'm still going to tape. Tomorrow will be Friday, capital F-R-I-D-A-Y. And we're going to end it with a period. And I'm going to move my eraser. And we're going to write what today is. Today is capital T-O-D-A-Y, face space, is, face space, capital T-H-U-R-S-D-A-Y. Oh, I forgot a period up here. Good thing I checked. And I'm going to put a comma because I'm going to continue this, right? Today is Thursday, April, capital A-P-R-I-L. And yesterday was the 8th, which makes today the 9th, the last single-digit day in the month. Tomorrow we roll up to the double digits. And it's 2020, right? I put a 2 in the thousands place. I put a 0 in the hundreds place. I put a 2 in the tens place. I put a 0 in the ones place. 2020. Yesterday was Wednesday. Today is Thursday. Tomorrow will be Friday. Today is Thursday, April 9th, 2020. Or, I'm going to put it small over here because I need this space. Or, January, February, March, April. Or, 4, here those rhyme. 4-9-20. All right. I want to math it up. Whoop, whoop. Okay, mathematicians, put on your super mathematical thinking brain and let's turn ourselves into mathematicians. Hocus pocus, don't lose your focus. Abracadabra, alakazam. We were mathematicians. Now we're mathematicians. Well, that's what I am. You too. Math, for some people, they say, oh, it's so hard. But what's hard is it takes a lot of brain power. And we've got that power in our own smart brain. So math is like a game, like solving problems. Uses a lot of brain power, and you can do this. So I'm looking up here at what I see on the board, and what you notice is there's an object over a box. An object over a box, an object over a box. So there's a string of objects over a string of boxes. Then underneath, there are the same kind of objects, but they're set either in an array or in a scattered configuration. So there are two different tasks. So we're going to start up here first. What I'd like to do is, even though this isn't a number line, I can turn it into one. So here is my string of numbers, and all I need to do, and I'm going to add 0, is add my arrows to both ends, and then draw a line straight across connecting my arrows. And above each of my numbers, I'm going to put a dot so that we know that these are whole numbers and there's an equal value between each of them. They represent 1 and 1 more and 1 more and 1 more and 1 more. And our value, our starting value and our ending value on our number line are 0 and 10. But a number line doesn't need to start with 0. We could do a number line just like this. We could drop it in anywhere on the continuum of numbers, and that number line could represent that block of numbers. So I don't want you to get the misconception that every number line has to start with 0, because if you were using very large numbers, it would take you a long time to make that number line. And anytime you're trying to figure out how to move up or down within a number sequence, what you can easily do is just construct a number line. Drop it in with the base number being the lowest one you'll use, and then the highest number will be the highest one you can use. And then you can draw on the number line, draw on the frame, and this becomes a structure that has a function of serving you to help to know how to count forward, count back, find missing numbers, all kinds of great things. So I'm going to put this back up because I am using 0 to 10. Now what the purpose of this task is to figure out the count sequence as represented by one and only one object, which increases by a value of 1. So I don't see no hearts here, 1 heart here, 2 hearts here, 3 hearts here, 4 hearts here. That's not what I'm doing. I'm not showing the amount. I'm showing how it sequentially rises by a value of 1. 1 and 1 more, 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 all the way down. So in my first box, I'm going to represent that with the numeral that shows the empty set, which is 0. Be my echo. Fly left around the world like a superhero. That makes 0. Now we go forward. What comes after 0? This is in the place of number 1. A straight line down is fun. That's 1. Count 1 more in the count sequence. This is in the place of number 0, 1, 2. Loop around to the right at a left angle, come down. A line right across the bottom will do. That makes 2. And 1 more. 0, 1, 2. What comes next? 3. Go right around the tree, right around the tree. That makes 3. Now my little poems are ones I've made up or made similar to ones that I heard. You don't have to do these poems. You don't have to do any poem as long as you can construct it independently. But the reason for doing a little chant or poem with each one, a little sing-songy chant, so that our brain remembers which directions to go, what the structure looks like. We're putting words around these symbols. So for children who are auditory, who need to hear things, and children who are visual and kinesthetic, this gives you an anchor point because we're talking about it, we're drawing the picture, and we're moving our hands. So we're getting all of those senses used. So no matter how you have input come in, my goal is that your output looks consistent and similar. Once you know how to do these, you don't need to fall back on these silly little chants. But I like my silly little chants. They're fun to me. Fun to me. I have a low threshold of fun, right? Okay, let's get back to the learning. So if I look up here, I have 0, I have 1, I have 2, I have 3. I want to make sure that I remember that this is the left, and I'm going to put my left hand up. Remember, L lives in my left hand. That's right. L is in my left hand. That's right. And that little mnemonic just reminds me that the left is in this direction toward the numbers that are smaller, and the right is in that direction toward the numbers that are larger, the bigger numbers, greater than and less than. It's important that we use lots of math vocabulary because we not only will sound intelligent, but we will also be intelligent. And it is good to be smart. I love in Spider-Man that you never, ever, ever apologize for being the smartest one in the room. That's worth thinking about. So after 3 comes 4. So this is 0, 1, 2, 3. This is sitting in the 4th place. Down and over right looks like a capital L. And down some more looks like a lowercase l. That makes 4. 0, 1, 2, 3, 4, 5. It's an odd number. Across left and down, loop right around. That is how we jive when we make a 5. This is in the place that's holding a space. Just a placeholder. 0, there's 1, there's 2, there's 3, there's 4, there's 5. This total shows a value of 1 more than 5, which is 6. Add a left angle, come down, loop right around. That is how we get our kicks when we make a 6. 1 heart, 2 hearts, 3 hearts, 4 hearts, 5 hearts, 6 hearts. What comes next? 6. After 6 comes 7. Fly right across the sky and at a left angle down from heaven. That makes 7. 1 heart, 2 hearts, 3 hearts, 4 hearts, 5 hearts, 6 hearts, 7 hearts. What comes next? 8. It's an even digit and an even number. Make an S down through the garden and then go back through the gate. That makes 8. Our last single digit number, which is the date for today, is, if you said 9, you were correct. And 9 is an odd number. Make a loop to the left on the right add a line. That makes 9. Now we're completely out of single digit numbers. So the 9 is going to roll back to a 0 in our pattern. And the 0 that we don't write, but it's implied in front of all of these numbers, is now going to roll up to a 1. 1, 2, hearts, 3 hearts, 4 hearts, 5 hearts, 6 hearts, 7 hearts, 8 hearts, 9 hearts, 10 hearts total. And they're sitting in each place, showing, if I do this, you'd say, oh, this heart is sitting in the 6th place. Oh, this heart is sitting in the 3rd place. So now we're going to write 10. I put a 1 in the tens place. I put a 0 in the ones place. 10. Now when I come down here, I see sets or groups of objects. And I want to count to see how many in all, and then I want to record what I see here. So this is another structure that we're going to use, and these are called, do you know what they're called? This is a number line. This is a number bond. Kind of looks like science when you see how cells bond together. Well, these numbers are going to bond together. So I look at my first scattered configuration because it just kind of dropped onto the board. And what I see is 1, 2, 3. So all together, there are 3. 1, 2, 3. Go right around the tree, right around the tree. That makes 3. So I see 3 total. But how do I see 3? There's some space in between these. So I see 3 as 2 hearts and one more. So how I can break down my bond, how I see 3 is 2, 2, and one more. Now I'm breaking it apart. So this is subtraction. 3 take away 2 equals 1. 3 take away 1 equals 2. See the total of 3? If I take 2 away, you only see 1. If I take 1 away, you still see 2. But what if I wanted to turn it around? Because I can use the inverse operation to check and see that it's correct. So I see 2 and 1 more. 2 and 1 more. And 2 and 1 more is a total of, I'm going to put the 2 in my head and the 1 in my hand. 2, 3, 2, 3. So 2 and 1 more equals a total of 3. So I'm bonding them together. 3 as 2 and 1 more, 2 and 1 more is 3. So this is what I see, and this is how I see it. And this is the inverse operation of how it could be. So I'm going to erase my digits, and I'm going to show the next one. Here I see a total of 1, 2, 3, 4. Now I could have said, I see 4. And I would have said, are you sure? For sure? How can you know for sure? We could count them, which is what I just did. And I touch and count them once and only once. I can't count them more than once, or I will be giving an incorrect value for how many in all. So here is a total of 4. 1, 2, 3, 4. I come down and I can see the 4. Down and override and down some more. That makes 4. But how did I see 4? If I look careful and I subitize, I break them apart, I see 4 as 2 and 2 more. So 4 decomposed, taking apart, is the same as 2 and 2 more. Now there are other ways to make 4, but not in this set. Now if I wanted to put them together, I could say 2 and 2 more bonded together. I'm composing, putting them together equals 4. Now if I came up here, I could also use the number line. I could say 2 and 2 more. 1, 2 more equals 4. So I can use multiple tools to help me check and recheck. I don't just have to rely on my own smart brain and my automaticity. I also want to check, and I want to be able to explain my answer. Because now in math, it is great that you get the right answer, and that's super important. But now you have to tell someone how you know that's the right answer. How did you get there? And when we do it all together in collaboration, what happens is your learning can inform my learning. You might see something and say something that I didn't see and I wouldn't know to say. And then I'm learning from you. So not just one person in the room is the teacher, but everyone in the room, every learner is also a teacher. There's something cool about that. So if this is my answer, I need to be able to defend it, defend it, defend it. And here's where I get the proof that this is the correct answer. It might be my answer, but it might not be the correct answer. I need to be able to prove that it is the correct answer. And by using some other alternate tools, I can. So if you were going to solve this problem on a paper, you too could make a number line to show it, or you could make a series of objects and you could label them with their corresponding numbers, and you could reference that and explain how you found your number, how you found your answer, and how you can defend that it's the correct one. Now the next one is pretty large. I love these because they kind of look like monsters to me. They look like monsters. Like he's like the legs. And this is like, and sometimes math seems so monstrous that you should be using some monsters. All right, so here is the next set. When I look at it, I think there's 5 there. Are you sure? For sure? Kind of maybe? How can I know for sure? I can count them. Touch and count them. So let's do that together. 1, 2, 3, 4, 5, 6. Ooh, I thought there were 5. But when I counted them, the last number that I stated is the total number in all, and I said 6, not 5. It was a good idea that we went back and checked it together. Errors are totally common, and what we know is that making mistakes is totally expected, especially in math. It's very easy to think you see something and then be surprised that what you saw is not what's really there. But this is where inspecting mistakes becomes critical, because I need to figure out why my brain thought there were 5. And then when I counted, there were 6, and it almost seemed like the 6th one just jumped on the board, like it wasn't there when I looked at it the first time. So in math, checking and double checking is really important, because math does have definitive answers. There is a correct answer. It's good to know how you got your answer, but it's also important to get the correct answer. And because it's exact, it's really important that you check and double check and double check. That's why numbers can seem so tricky, because they just seem to change sometimes in your mind. They don't really. But that's why using strategies and tools are really important, because we have to respect the value of making mistakes, especially in math, because that's how our math brain grows. Compressions are made when we make mistakes and we correct them. My brain thought one thing, and then there was this like air in my brain when I counted 6. It was surprise. And then I looked closer, so that if I were to see this array ever again, my brain would remember, ooh, we said 5 and it was 6. We said 5 and it was 6. So my brain is going to be inclined to jump to the truth of the answer, which is 6, and then to go back and check to make sure. That is how we're helped to learn. So in math, making mistakes is really valuable. It's also super frustrating. So it's very important to be mindful. So I'm just going to pause for a second. I'm going to take a deep breath. I'm going to let it go. And I'm going to smile. I'm showing teeth. And smile. Pause. Breathe. And smile. I'm learning, and I need to remember that. So my heaviness will fall into my frown, and I want to push it back up with my smile. I'm learning. That's really important. It doesn't feel good sometimes, but it's really important. One day I'm just going to look at this and go 6 and be correct the first time. But today was not that day. Maybe tomorrow. So I see 6. How do I see 6? Now because it's an array, there's a top and there's a bottom. So it's very easy for my brain to subitize and see this many and this many more. This is such a large amount, though. I want to check, especially since I said 5 and there weren't 5. 1, 2, 3, and it looks like it mirrors it. It looks exactly the same. Let me check. 1, 2, 3. So now I see 6 as 3 and 3 more. And if I flip it over, I can make 6 with 3 and 3 more. Decomposing, composing. Decomposition, composition. This one I'm taking apart. This one I'm putting together. This is subtraction. This is addition. So one of the things that I could do is use the symbol that shows this plus this equals this. And equals can be a line if I'm going vertical. It's just a line. But if I'm going horizontal side to side, it's a line over a line. And it equals 6. This is minus and equals. So 6 minus 3 equals 3. 6 minus 3 equals 3. Woo! Very, very tricky, isn't it? Okay, and then I have one more left. So I'm going to erase this and erase all of my equations. And what I just did at the bottom is I made an equation. So when you see the numbers and the symbols, then it's called an equation. Now I'm doing the equation in my head. But when I put it in that format, I'm doing the equation on the board. There's only one left. Do you see it? It just has 1. So how do I see 1? This seems funny, right? I see 1 as 1 total with 1 and how many more? I know, it seems like a trick, huh? Not a trick. 1 and how many more? 1 and no more. So I see 1 as 1 and 0 more. I can make it by saying 1 and no more equals 1. I can further put that into an equation by saying 1 plus 0 equals 1. That's vertical, up and down. Or I can say 1 plus 0 equals 1. Any number plus 0 equals that number. And, oh, I just did this one. See how I made a mistake there? That is 1 plus. This is 1 minus. 1 minus 0 equals 1. And any number minus 0 equals that number. And 1 minus 0 equals 1. More mistakes. More mistakes. The phone was very distracting. I did want to point something else here that I saw. Did you notice that this is 2 and 2 more, and this is 3 and 3 more? When we look at math, we call these doubles. So this is doubles. When you double 2, it becomes 4. When you double 3, it becomes 6. So one of the strategies you'll work on later in like 2nd grade is looking at doubles, maybe in 1st grade. Looking at how you can memorize the doubles so you don't have to count them. So when you see them, your brain will automatically put them together and populate the number that they equal in all. That was such a fun time on our calendar. I'll see you on a different video. Until later. Goodbye, super smarties. Make sure you come back ready to learn. Have some pride. Here's my schema. Don't take it all. I need some. Here's some pride. Put it inside. Here's some love. Keep that for later. Until later, super teacher.